Hey, this is Mr. Elmhorst with the help video for the minor grade understanding ratios in different forms. First thing you want to do, let me turn on the marker, is we are going to start with the part total. So we're going to set up girls, students, and then boys is the other part. So you can do G, B, and the total number of students. So we're going to set up our part total table and then fill it in with the information. The girls is given is 18. The total is given, which is 30. The difference between 30 and 18, how many are boys? Whoa. If it's a question for the video, you guys are welcome to answer. Just please don't shout. Okay, now if you look at your answer choices, the ratios are given in decimal form in tenths and hundredths. So completing our table, we can just do an easy trick here and we can fill in tenths and hundredths. Now, using some simple math, logic, and reasoning, how do you go from 30 to 10 in ratios? Divide by 3. Okay, so we're going to divide each one by 3 to help us write an equivalent ratio. So that's 6 and 4 in percent. That would be 60 and 40. We go to the question. Go ahead and answer the question. It's asking about girls. So looking at question 2, we have the part, which is the percent, and then the total, which is out of 100. The part total, we're looking at chicken nuggets and pizza. So we go to the table and it says or, we don't know which one, so we're going to do both. So we're going to put the percent for chicken nuggets and pizza together, and that's going to give us a total of 60%. Please don't shout. So then we're going to fill that out, 60 out of 100. Now, you look at your answer choices, and they are in simplified fraction form. So it looks like 60 can be divided by 10. 100 can be divided by 10. That is not the most simplified version. What else can we divide both of these by? 2. So that's going to give you 3 out of 5. So finish the table. Easy peasy, answer the question. So we set up a part total table to represent the context. We have never been and have been. So we can say never been, NB, have been, HB, and the total is the percent. Percent is out of 100. Okay, so now we go to never been, which is 16. The total is 100. So if there's 100% and 16% have never been checked out, what is the has been? 84. 84. Okay, so now we set up the part total, and we're going to look at the ratio, which represents the books that have been to the total numbers. So simplifying this, we need the have been and the total. What can we divide 84 by? That also works with 100. 24 might work. I know 4 works. 24 does not work with 100, so we're going to divide by 4, and we've been working on that since the beginning of the year. 100 divided by 4 is? 24. And 84 divided by 4? 24. Okay, so looking at number 4, we're going to set up the part total. We have pennies, dimes, and then the total amount of money. So it says pennies, there's 24, and we're going to put that in dollar cents, and then there's $1.04. So we set up we have 24 pennies, which is 24 cents, and we have $1.04. So how much money do we have in dimes?
80 cents.
That's going to be 80 cents. All right, so now it's asking about pennies and dimes. This is 24 pennies. And then we do a little math reasoning. There's 80 cents, which is going to be 8 dimes. And it says simplify the ratio of 24 pennies over 8 dimes. What can we divide both of these by? You can't divide by 3. You can divide by 2. You can divide by 4. You can also divide by 8. So looking at number 5, the context is you have candy and your friend has candy, and you're going to set them up in a part, and then compare that to a percent. So your candy is 16. Your friend's candy is 20. Now, the percent is going to be written as a total of what? Percent is out of 100. Now, looking at our math factors from the beginning of the year, how do we go from 20 to 100? Times 5 times 5. So the solve, go ahead and multiply that out. No, I said multiply it out, not blurt it out. So looking at number 6, the context is bringing pencils to class and not bringing pencils to class, and then the total number of students. So we have part total. So we have 120 students bring their pencil to class, and there's 150 total students. So if there's 120 bringing pencils, how many are not bringing pencils? 30. Okay. And looking at your answer choices, it looks like we need to simplify and compare to tenths or hundredths. 5 tenths or hundredths. So simplifying, we could probably divide this by 5, divide by 5. I think there's an easy one. Let's do 3. I'm going to divide by 3, divide by 3. So that's going to give us 40, 10, and 50. Divide by 5, divide by 5, divide by 5. We can simplify. That's going to give us 8, 2, and 10. So the question is not bringing. So we have 2 out of tenths. 2 out of tenths. 4/5 is too big, so you should be able to see your answer at that point. So number 7, we're setting up the part total table. We have sleep, awake, and total. So how many sleep hours does Bonnie get? How many total hours?
24.
So that means she is awake for how many hours? 16. And then we look at which ratio correctly compares the number of hours she sleeps to awake. Sleeps to awake.
Divide them by 8.
Divide both by 8 is the greatest factor. And that should get you to the simplified version of your answer. Okay, so we have imported vehicles, North American vehicles, and then the total number of vehicles. So there's a total number of 42 cars in the parking lot. How many vehicles are imported?
24.
So we have to fill in the missing part. How many are North American vehicles?
18.
So 42 minus 24 is going to give us 18. So we go to the question, we have the ratio of imported to North American. Imported over North American. What can we divide both of these by? 6. So that's going to give us 4 over 3, and then you can simplify that for your answer. All right, looking at context number 9, we have shaded, non-shaded, and then total squares. Do we count up how many shaded squares do we have? 15. And how many non-shaded do we have? And total? 20. And lowest terms, looks like we can divide all these by 5. That's going to give us 3 to 1 to 4. And it's asking for shaded to total. All right, and for the last question, just to finish up the video here, we have large containers of milk, small containers of milk, and then the total. So there's 4 large, 7 small, and a total number of 11. Which ratio could represent the large containers of milk to the small containers? So we could just write some equivalent ratios here. Times 2, times 2, times 2, times 3, times 3, times 3. So we look for the ratio 7 over 4, we don't have that one. 21 over 12, we don't have that one. 14 to 8, it looks like that one is there.